Hey, so it's time to talk about plate tectonics, and we're going to start off with a phenomenon. So this guy over here, Mr. J, is going snorkeling, and he's going snorkeling in freezing cold water. I mean, it is just above freezing actually, and that's okay because he's well insulated. The interesting thing here is, of course, that right over here, this is actually part of Europe. And right over here, this is part of North America. Now, if you're familiar with the map, this might be a little bit confusing to you. So I want you to make a prediction. How is it possible that this is taking place right now? So I want you to think. Again, as I'm coming through here, I didn't get a photo of this exact thing. I couldn't take a photo of myself, of course. But as I was going through, you can actually put your hand on Europe and your hand on North America and touch two different continents at the same time. One of the cooler experiences of my life. So we're actually going to come back to that later on in the unit, but I want you to, again, make your prediction about what it is. We're going to take a little detour right now, start talking about the layers of the Earth. So please jot this down into your notes. I actually believe I handed this out as a packet. So some of it may be already written out for you. Basically, if anything is on a line over here, that's what you should write down on the line that's there. So anyway, we're talking about the composition of the Earth. Composition is what something is made out of. So that's what we're focusing on right now, is we're breaking up the layers of the Earth into the crust, the mantle, and the core. There's actually two different types of crust. We have the continental crust. This is, of course, all the land that is above the ocean. It is the continent. So when you look at the map and you see any of the continents, that's continental crust. Now, it's mostly made out of granite, which is a type of igneous rock that's formed on the inside of the Earth. And we'll talk, there's a whole bunch of other different types of rocks too, but a huge chunk of it is actually made out of granite, more than you might expect. The next type of rock we're going to talk about is oceanic crust. So this is made out of a different type of rock. This is an extrusive igneous rock called basalt. This is what basalt looks like over here. It's not very spectacular. It's a denser type of rock, a little bit darker, and it's formed on the ocean floor. And it is the oceanic crust is basically all the land that exists underneath the ocean. So if you were to kind of suck up all of the water out of the Earth, which this video is doing right over here, what's left over here would just be the oceanic crust. Of course, the continents are the continental crust, and then we have the oceanic crust underneath that, mostly made out of basalt, like we talked about. The next definition is the mantle. The mantle is located between the crust and the core. I like this kind of like nesting doll structure over here that they have. And the mantle is by far the largest layer of the Earth. A big chunk of the mantle is actually made out of this material called olivine, which is a mixture of iron and magnesium, two elements on the periodic table there. And olivine is interesting because it has this obviously green structure over here. This is the crystallized structure, and this is just kind of the regular rock version of it. And you might be saying, well, hold on a second, Mr. J. This is very reddish, orangish, yellowish, and this is very greenish. What's going on? Well, you basically take any rock, and if you put it into its molten form, the liquid form, it's going to look more like this color. So regardless of that, it's not going to be liquid green, although that would look pretty cool if it was. Underneath the mantle, we have the core. So the core is located below the mantle. This is at the very center. And of course, this image could be reflected, just go the other way too, where like this half is again on the other side, encasing that, same thing on the other side. It's mostly made out of iron and nickel. So these are the densest materials. When the Earth was originally forming, long time ago, about 4.5 billion years ago, it was basically a giant lava planet. The outermost layer of the crust hadn't cooled down yet, so it was kind of all like the mantle over here. And there was this event that's called the Iron Catastrophe, which I always thought would make a really cool name for like a heavy metal band, the Iron Catastrophe. What happened during that is the densest materials, the heaviest materials, all sank to the very bottom over here. I mean, this happens all the time. You've seen that before. Heavy things sink, right? In water, if you look at it, heavier things sink down. So that's what happened over here. Although it wasn't water, it was liquid rock. And the heaviest metals all sank down to the very center over here. So this is what a mixture of iron and nickel all fell down right there. Now, if you were to look at the tectonic plates, this is the crust, right? The tectonic plates are composed of two different things. We have continental crust, and oceanic crust. But all of this is considered one plate. So this is the South American plate. It includes the Andes mountain range. And you can see that the very tippy top of the mantle is also included as part of that. So you see that when there is a tectonic plate, it actually extends beyond just the continental crust, which we're most familiar with. If you look over here, you could see that the mantle is 67% of the Earth's mass. So about 2/3 of the Earth's mass is all within the mantle, and about 1/3 of the Earth's mass over there. And if you're doing your math, you're saying, well, 2/3 plus 1/3 equals 1. So what's remaining, just less than 1%, is actually the entire crust. So everything that we're on, the outside of the Earth, is only in that little 1%. Mars is, I believe, like 1/6 the size of the Earth overall, but it's only got 11% of the mass of Earth. So it's a lot less massive, obviously. And you would have to assume that its core is much smaller and has less dense material inside of it overall compared to ours.